In this question, we are asked to find the area contained within both the curve r of theta equals 3 plus 2 cosine of theta and r of theta equals 3 plus 2 sine of theta, plotted below. The red graph is 2 sine of theta plus 3, and the blue graph is 2 cosine of theta plus 3. They intersect at theta equals pi over 4 and negative 3 pi over 4, or 5 pi over 4, depending on which way one goes around the circle, because those are the points at which sine and cosine are equal. We want the area within both curves, so we ignore the area outside of the blue curve here and outside of the red curve here, meaning this is the area we are looking for. However, one will notice that these two areas are equal. The shape is symmetrical. Therefore, instead of using the equation 1 over 2 integral from a to b of r squared d theta, we can use simply the integral from, in this case, negative 3 pi over 4 to pi over 4. Without the 1/2, because the 1/2 is cancelled by the 2, because it is two equal areas. So, from the angles I have selected, we are limited by the red function, so that's 2 sine of theta plus 3 squared d theta, which simplifies to integral from negative 3 pi over 4 to pi over 4 of 11 plus 12 sine of theta minus cosine of theta, or cosine of 2 theta, using the half-angle formula to simplify the square of cosine at the end. The square of sine at the end, d theta. I've got the over 2. And this, in turn, goes to 11 theta minus 12 cosine of theta minus sine 2 theta over 4 from negative 3 pi over 4 to pi over 4, which is equal to 11 pi over 4, or 11 pi, because it's 11 pi over 4 plus 33 pi over 4 when you cancel the negatives. Six square root 2, there's a negative on the first part of the equation and a positive in the second part of the equation, so those will cancel. And then minus 1/4 for sine of 2 theta over 4. Sine of 2 pi over 4 would be sine of 1/2 over 4. And then on the other end, it would be adding 1/4 because sine is negative in the third quadrant. So those also cancel, giving you a final answer of 11 pi over 4 units squared.